Hello everyone. This is Aman and from Uplatz Technologies. And today we will start the Snowflake. Okay. So in previous lecture we have studied variety of concepts and related to data warehouse, and Snowflake is one of our data warehouse. So all the concepts which we have studied in our Snowflake in our data warehouse, that will be ultimately used in our Snowflake. Okay. So in today's lecture, we will try to log in into the uh, our database, Snowflake data warehouse, and then we will understand some basic GUI, and then we will understand the architecture of the data warehouse, that is a Snowflake, and then we will proceed further what is virtual warehouse, and we will deep down into the Snowflake architecture. Okay. So first let me log in into our data warehouse. How will we log in? So what you have to do, you have to just come here and write Snowflake. Okay. So once you write Snowflake, I have just written anything. So you will get this, come on this www.snowflake.com. When you come here, it will, okay. So their portal has been updated now. So you can select here, start for free. Okay, once you log in here, Snowflake trial. So Snowflake gives you a 30-day trial, or it gives you some 400 credits. So when you fill the details, you will be able to see the things. So here I will, it will ask some details. You will be mentioning this. Okay, so I am just giving you some name, video, and I have a mail ID. That is, this is the mail ID I have. So put it here, and I'll put a simple student, and then I'll continue. So here, then you will get a chance to choose your Snowflake edition. So we can choose the anyone according to the requirement, but our as we are using it for a training purpose, so I am connecting taking a business critical, and this is the cloud provider. You can take any cloud provider, external cloud provider is there, and in cloud provider basically your data will be stored. This cloud provider will be used as a storage. Now as enterprises use a different storage systems, and they have their own cloud providers like Microsoft Azure and cloud platform GCP. So we take according to that enterprise what they are using. But in our case, we will be using only Amazon. Okay. So here you can put your region, Asia Pacific Singapore. But as I am here from India, so I am selecting this, and this is showing the location. Now you can click here for check here to indicate that you have read and agreed the terms. Now you can get started. So it will ask some question. Personal learning and development, continue. Java, Python, continue. And there you will, can skip this. Now signed on. Okay. So we will be having got some link on your video tutorial. So when you come here, when you refresh this field, so see here, you are in your Snowflake. So here it will giving you a link. And what is it is saying? It is saying congratulations on getting started with the Snowflake. Click the button to. So here, first you have to, now you have put your credentials in our, like on the portal. Now when you will click it here, it is for activation purpose. Your account will activate. Okay. It will ask some username. You can put your username into that. So if I am trying to video underscore tutorial, and okay, password I can put some passwords. So I'm also putting it. I've given some password. Similarly, I will repeat this. So I have given, okay, password is not matching. I have created an account. Save. So here you are now in Snowflake account. Okay. Here it will ask just skip for now. And now you are in the Snowflake account. Here you can see that your account is video tutorial is account name, and you have a 400 credits left for 30 days. There is one point to be noted. Snowflake do not give Snowflake charges not charges in the form of dollars. It will charge it in the form of credits. So what happens? It will take. Well, let me explain it. It will take your amount, like I'm a user, so I paid him some $500. So it will convert these dollars into credits. And now, as we will use the thing, you will spend in credits. Okay, so in this way it does. So here, if you see in the portal, here we have a 400 credits are left. Okay, now this is the what you have login. But come here, there is a this link. You can directly log in it with through the link. So I will copy this link. When you paste it here, okay, just okay, just when you enter, see here, you will be able to log in with this link only. So you can sign in here, sign in. So you can mark that link for user using purpose. Okay. Now if you refresh it, just a minute. Let me see. Okay. Okay, so this was the link which you have got in your mail. So you can directly click it and save that link for a future purpose. Okay. Now let me show you. I wanted to show one more thing. Yes, it will be always saved and sign in. Okay. So in this way, we will be logging into your video tutorial account. Okay. Now can leave this side as we do not need. We are in our own Snowflake account. Okay. Here today we will first understand the worksheet, because it has been from last three lectures we are only reading theoretical things and we are not practicing the on a GUI portal. So we will first understand worksheet. Okay. So here you can see in the left side there is a pane, and in right side all the things are there. Okay. So in left side, if you see here the snowflake is there, then when you click on the first button, create. So first create will show you some options. Here SQL worksheet, Python worksheet, and there is notebook. Okay. Notebook is you know that Python supports a variety of notebooks like Jupyter, Google Colab. Okay. So this notebook you can import. Then you can open the Git repository if you have. You can open the dashboards if you have. If you want to create any dashboard, that time you can create. Okay. So here by clicking on SQL worksheet, you can definitely create a worksheet. So you are in worksheet. Okay. Now, as you this is new, that's why you are getting this. Got it. Here, when you click there, so you have in worksheets. Now that you can create it from this plus one, or you can create the worksheet from by selecting creating here. You can create a worksheet, or you can Okay, now we can create a worksheet from here. Okay, in top of the thing, you will definitely on these three dots, when you click, you get a different options like rename, go to parent folder, import SQL or file, move to duplicate, format query, delete worksheet, and this type of things. Okay, so at this time, we saw that what is worksheet. Worksheet is basically a sheet where you write the code and we will execute this. So how it happens? Suppose here there are two things. One is database, another is worksheet. In worksheets, you will write the codes. Okay, but in databases these are the databases which is present in our Snowflake storage. Okay, so if I want to write some code like one more thing I forgot to explain it. When you click on plus, you will get a different thing like SQL worksheet, Python worksheet. So it gives you the option to write SQL code or Python code. If you are selecting Python worksheets, then you can see that you can write your Python codes here. Okay, you can write the Snowpark here. But if I am selecting uh, if I am selecting the SQL worksheet, so you will be writing an SQL codes. Okay, so I will close all the worksheets as I don't need. I will I will just show you a small example. Suppose I am writing a simple code. Select. So select is there. When you select here, no? Yes. So you can see the different keywords are getting reflected. It is automatically searching this select. And if I want to start from, this is the SQL code we write, and these two are the databases. Okay, so it will be having some schemas. We will explore this, but for the temporary purposes, I am just using it. Just I am using it for like here you can see this is customer data is already present. You can just click on these three dots and this gives you the option to place this file name in the editor. You can see. Okay, select a star from this limit 100. When you execute this. So here execution, you can execute this from here on as well, or you can select and control enter. Even then you can execute. So here you can see that it has been executed. These things we will discuss in the coming classes. Just try to understand what is worksheets. Okay. Now here you can see the data is loaded, and once you will see that this is the hide status, you will get some rows. How many loads has been loaded? So we have limited it to 100. So we have 100 rows. Now each whatever the query executed, it generates a query ID for each and every query you execute. So here you will get the query ID and your data is uh, mm, data has been loaded in or from Snowflake to our page. Okay, so I think I was able to do. Okay, you can rename it. We can rename it by selecting it here, or you can rename it by double clicking, and you can rename it sample. Any name you can give it. So sample it is there. When you click here, you can order it as well. But if you want to have some folders here, so you can create a folder. Like if I want to create a folder, demo lectures. So you can create a folder and empty folder. So this is a demo lecture. You can add some SQL worksheets. So you can see that we are in demo lecture and now we have a this worksheet. So I can rename it demo 1. So you can see like demo 1, you can hide it. This can be hidden. So this sample is in benchmarking tutorials and demo lecture inside demo lecture. You click here, we are in this worksheet. Okay. So this was all about worksheets. Worksheets is basically it's like a notebook where you will write the code and you will execute this. And for execution, you can execute it by pressing this run button, or you can execute by control and enter. Okay. Now we'll okay. So I forgot to tell you. Okay, we will discuss this. Now we will discuss about the architecture of the Snowflake. So this is what we have uh, saw that what is the worksheet and how things are there. Let's discuss about the architecture. I think that this is very weird to discuss it like this. Okay, so first we will read something about this. Snowflake is a true self-managed service. Okay, so what there is no hardware physical or to select install configure. So you can see when we open our Snowflake, okay, that time we do not need to install any or configure anything in our data warehouse. We were not configuring anything in our system. Okay, there is a virtually no software to install, configure or manage. So there are no any softwares which is required to be installed. Okay, in Snowflake. Ongoing maintenance management, upgrades and tuning are handled by there is a Snowflake team which handles all the things. So you can see that we simply log in into our Snowflake data warehouse without installing anything extra. It is self-managed tool. That's why it is famous in the right now in the market. It is the most used Snowflake data warehouse right now. It is most used data warehouse because it is cheaper and it is very easy to operate. You can very easily write the codes. So let me bring you just some content. Okay, see here. So this is a documentation from Snowflake, and I will discuss that thing. Okay, now we will be discussing the Snowflake architecture. Snowflake architecture can be divided into three parts. Okay, Snowflake has basically three things. First one is storage, which is here, three layer. It is a three-tier architecture. Sometimes it is called or three-layer architecture. Okay. So what are these three layers? First one is database storage. In database storage, you can see that our data will be stored in the database storage. Okay. Second is one is query processing layer. This query, it is a query processing layer where we will execute the queries. Okay, where our compute engines will run. And third one is cloud services layer. This is the layer which will manage the all the infrastructure manager, optimizer, metadata management, security, authentication, and access control. These all things will be managed by our uh, uh, cloud service layer. Each layer we will study in a depth and in a more better way. So first thing is data storage. When we were creating the Snowflake account, that time I told you that this is the storage. Like we have got some three options: Azure, AWS, and GCP. Okay, so that is the storage. It is referring to data storage because it uses external storage database. Okay, it uses external storage database. All the data which you will bring into our data warehouse, all the data gets stored in our all the data which you bring in the Snowflake, it gets stored in our external storage system. That is either external storage cloud, that is a Snowflake Azure, AWS, or Google Cloud. Here it is mentioning when data is loaded into a Snowflake. Okay, so I told you, but before that, what happens? Before that, what happens? Let's discuss. Suppose you are bringing your data and storing it into bringing your data and storing our data into there. When a data is loaded into a Snowflake reorganizes the data into its internal optimized compressed columnar format. Suppose you are bringing 100 GB of data. So what we'll do? Let us again draw the diagram of data warehouse architecture. Okay, that will for better for us. Suppose this is a source 1, source 2, source 3, and this is the source 1, and this is the you brought your data into a Snowflake. Now you brought some 100 GB of data. So in that case, what do you think? All the data will get stored in the same way. So you know that ETL is there. But even after this, our data will store in a more organized way so that our analytical process become fast and we can do high level of analytics in a very less time. We can do analytics in a very. So in that case, our data will reorganized in a such a way that the we can perform the analysis more faster. First, second, if you are loading the data in like 100 GB, that case yesterday we discussed about uh, columnar storage. So our data will get converted into columnar format so that the storage becomes reduced. So if I am loading some 100 GB of data now, it will get reduced to 80 GB or more or less 40 30 GB. This amount of things it gets reduced. This gets reduced by these limits. Okay, so storage is a basically we are keeping our data in our storage part, and this is a external cloud provider. Basically it is a external cloud provider, and here the data is optimized, compressed, and columnar format. Okay, now just a minute. So this is like this. Now we will discuss about the second layer, which is a compute layer or query processing layer. So all the things, suppose you write a query here. Here you write this query. Okay. So you write this query. Now you executed this. So this query needs to be run. You run it, you give it command to run. But who is computing this thing? Who is computing this query or who is executing this query? This query is executed by this query processing layer. Okay. So in query processing layer, we have a virtual warehouses. Okay. So here we have a virtual warehouse. Here you can see that we have a compute warehouse, run warehouse. Okay. So this is a warehouse and it is a one of the type of the warehouse. We generally call it a virtual warehouse. So what we'll do? So in query processing, you can see we have a different virtual warehouses. Now we'll read about this. Compute layer, it is a virtual warehouse. Virtual warehouse, often referred to as simply as warehouse, is a cluster of compute resources in a Snowflake. So what happens? This is a virtual warehouse 1, virtual warehouse 2. So this will contain some compute resources. Compute resource 1, compute resource 2, or it will have one can have more. Okay, this is a virtual warehouse 3. This is compute resources 4, compute resources 5. Okay, so when data is sorry, it will have some virtual warehouses, and these virtual warehouses contains some compute engines, and that runs and that get your query executed. We'll deep dive more in a coming today's lecture. So there are two types of virtual warehouses. One is standard and second one is snowpark optimized. Okay. So in standard is basically, you can see here, standard is basically it is used for day-to-day purposes. Like if you are executing some codes or you are executing some complex codes, that time you can use a standard. But for machine learning and data scientists or model training, in that time of case, we use Snowpark optimized virtual warehouses. Okay. Now we will discuss more about these virtual warehouses. Okay. Right now we will discuss it. Okay. What happens? Let me show you. This virtual warehouses, you can see here. This is warehouse, and you can see here size x1. Okay. So this virtual warehouses has some clusters. Clusters are there, and these clusters are compute cluster set of compute engine is known as clusters. Set of compute engine is known as clusters. So they have a clusters like one cluster, two cluster, this is cluster small. Similarly, we have a single cluster that is extra small. Similarly, we have a if I am having four compute engines, so it will be a large cluster. Okay, so in this type they have a compute engines, and each compute engines when it runs, it will charge some credits. That's why it is it cost is given in the form of credits. Okay. Now okay, let me tell you one more thing here. Here uh, here we are following shared nothing architecture in Snowflake. Why? In query processing, each warehouse, each virtual warehouses will have their own compute engines and on memory storage. Okay, so each virtual warehouse will have their own compute engines and on memory storage. But in case of database storage, we are doing shared disk architecture. In this, we are basically performing. We are our data is getting stored in a shared architecture format. Okay. One more thing I was discussing about MPP, how the MPP is applied in a this Snowflake. So yesterday we discussed now three concepts: cloud versus premise, MPP, columnar storage. So we are discussing shared nothing architecture. So in Snowflake basically supports both. It does a shared nothing architecture as well as is a in storage it uses shared architecture. For storage purposes, it has external cloud storage, and there we store our data. But in query processing, we are also following massive parallel processing. How? Suppose uh, we have a this query which we are using it. Now, this query, for this query, we can divide this query into subqueries. Like there will be a select on this. Okay, this is the like part one, and two, and select top 100 from. First we'll select this. Okay. So there are two parts. This is a part two. So what will happen in Snowflake? These two queries will be running simultaneously to each other. Okay, so this is a massive parallel processing. So in data warehouse, we have virtual warehouse. Often a similar warehouse is a cluster of compute resources in a Snowflake. Virtual warehouse is available in two types: standard and a Snowpark. A standard is basically we are using for general purposes, but for any specific like data modeling training or for machine learning, that case we are using uh, virtual compute layer and Snowpark optimized. Here we have some contents. You can go there, and once you read it, so here the data when data is loaded into Snowflake, that gets internalized. Okay, query processing cloud service layer. Now we will discuss about the top layer, which is cloud service layer. So these three we discussed about these two layers. What's the two layers? Query processing layer, database storage, and cloud service layer we are understanding. Cloud service layer is a collection of services that coordinate activities across Snowflake. So here in architecture, you can see data database storage is basically happening external, and this is query processing happening in Snowflake. Now there is necessity of something which manages all the architecture of the Snowflake. So cloud service layer has the responsibility to maintain the all the query processing, database storage, and cloud other things like metadata operation, infrastructure manager. These things to be managed by cloud service layer. Here you can see cloud service layer is a collection of services that coordinate activities across Snowflake. Okay, so this is basically coordinating all the activities that from where the data will be copied and which are the compute resources needs to be started, which are the compute resources needs to be closed or stopped. Uh, this will deep dive. So this type of activities are basically done by cloud service layer. These services tie together all of the different components of the Snowflake in order to process user request. So whenever it is ultimately saying that this is the layer which will direct all the activities which needs to be performed in a Snowflake from logging to query dispatch. So where this is cloud service layer. In cloud service layer basically maintains this type of activities. This performs authentication. So when you log in our Snowflake, it needs to be authenticated that a correct user has been logged in. In that case, this authentication is performed by cloud service layer. Then infrastructure management. So which are the clusters needs to be started, which are the cluster needs to be closed, uh, uh, whom we can allow to start the cluster, whom we can allow to the perform the operations. So this type of things are basically managed by cloud service layer. Metadata management is done by cloud service. Query parsing and optimization. So many times the query parsing is happening, and this is also managed by cloud service layer. Access control is managed by cloud service. So these are the some activities. So to do the things in a very brief, we can see that our Snowflake basically contains these three architecture, three layers, three-tier architecture. One is database storage, second one is query processing, and third one is cloud service layer. Okay. In cloud service layer, all the metadata and other operations are performed. In query processing, we have virtual warehouses, and these virtual warehouses contain some clusters, and these virtual warehouses are performing MPP, massive parallel processing, and each virtual warehouse is independent and they have their own compute power and CPU storage and compute power. Database storage is like it's a third party, or you can say it's a external storage which is given in a taken care by other party. All the data gets stored in that, and how the data gets stored? How data gets stored in the form of more organized and more columnar format, so that we can get the we can perform the analysis more faster and more better. Okay, so this was the cloud data warehouse Snowflake architecture. Now we will understand how we can set up a virtual warehouse. Okay, then we will understand the database and schema and we will close the lecture. So when you come and log in here, we saw that for execution this we need to execute and we need some compute engines to execute this. Okay, so how? So this is the virtual warehouse which is running. I have named it as a compute WH. Okay, and here the size is mentioned. Okay, so first uh, we will uh, we will see some basic funda about uh, virtual warehouse who can create. So let us discuss more about this GUI. So when we have discussed about worksheets. Now I saw that how the demo is happened. Now here if you see in right side here you are getting the role, and just right of that we are getting run on warehouse. Okay, and here you are share and here are some more options. Now in right side when you're clicking you are getting some compute underscore warehouse and here access mode. So basically what happens, Snowflake charges the users in the credits, but they are making charges on the basis of two things: how much they have used the computing powers and how much the data is used in storage. So I will try to explain this. Okay, and then we will proceed further. So first we will create the data this virtual warehouse. So how you can create for creating a virtual warehouse, this we will discuss that in the future about the roles and responsibility. Each role has some. You need two type of access. You only two roles can be create. Two roles can create a virtual warehouse. One is account admin and second one is sysadmin. These two peoples can uh, create a virtual warehouse. Okay. Okay. So for creating a virtual warehouse can be created in a two way by using a this GUI and by writing the SQL code. So we'll write the SQL we will create the virtual warehouse by writing the SQL code and as well as using a GUI. First we will execute use with the help of GUI. So first requirement is that to create a virtual warehouse, you have to first be the either two role you should have, either account admin role or sysadmin role. These two people person having role of this can create. So let me show you. When you are in account admin, you have selected your account admin role. Okay, here you can know. And now when you click here and you can come on warehouses. So you can see there are two warehouses you can see. Okay, but when you come and change it like make it is a public, so you will not be able to, that compute warehouses has been lost. Okay, if I am, he is not able to see. Okay, just one more thing I want to explain. When you click on account admin you can see the option plus warehouse. So here it is giving you the all the warehouses which is present in your Snowflake, and as well it is giving you the option to create. But when you change it to public, you are not able to see that virtual option to create a warehouse, as well as number of warehouses you are seeing, it has been limited. Okay, now when you click on sysadmin, so in the same case, the you are able to see this virtual warehouse, but here you are getting the option to create a virtual warehouse. Okay, So actually the creation of the different things like databases, tables, and virtual warehouse depends on that what type of role you are having. In this case, I will be using only account admin role. So I have account admin role and I am able to see that what are the virtual warehouses I am having and I can create this. So creation of virtual, how you have to create? Just come here and click on plus. Now it's asking for uh, what is the name of virtual warehouse. So I am just giving demo underscore wh. Okay. Second is you can add some comment as well. This is used for demo. Okay. Now here we will discuss different things. Type. Here we will see you are getting two types, standard and snowpark optimized. That is what we have here brought. Discussed standard and snowpark optimized. So when you come and read this, standard warehouse can be used for most workloads, including Snowpark. And Snowpark optimized warehouses offer a larger memory and cache. They are often used for memory-intensive operations. So you might have known about PySpark. So there are many times in-memory databases. We have studied in our lecture that in-memory databases, what happens? The execution of the code happens in the memory of the database. This is what Snowpark Optimize gives you the. They are often used for memory intensive operation. Sometimes it gives us the memory intensive. It will help you to act as a, you have to operate some. You have to execute some codes in memory. This will help you with this. If you are using uh, your data for model training, this time you can use. So according to the requirement, you have to select. So I will select only standard. Now come to size. In Snowflake, we have a some limited amount of size. See, extra small, small, medium, large, extra large, 2XL, 3X, 4X. So when you cancel this, now here you can see clusters. So if you come here and when you click here, so what will happen? As the clusters of the size gets, as the size gets increases now, number of clusters which are there, number of clusters which are you watching will be increased. So here, if you see this is extra small, and how many clusters it has? 10 clusters. So you are getting your clusters will get increased. Okay, and according the cluster, it will charge. How it is charging? For extra small, if you are continuously using for 1 hour, it is charging 1 credit. For 4XL, if you are using for 1 hour, it is charging 128 credits. So your charges are depending, this pricing in the Snowflake we will discuss it, but your charges are depending basically which cluster you are using and how many hours you are using. So okay, now we'll create it. So I'm just giving demo underscore wh wh. Now if I want to write some comment that is not component video demo, then I am selecting standard. Here you can select multiple things. Now this is what you all need right now. But once you click on advanced option, there are some options. First is auto resume. Auto resume means whenever you will execute some code, it will get auto started. So it automatically resumes the warehouse when any statement that requires a warehouse is submitted. Okay. So this means auto resume. Auto suspends means whenever you are not using your data warehouse, that time it will get automatically stopped. It will not run. Okay. So if you need, you can suspend after, because it will need after how many minutes or seconds we want to suspend. So it is giving minutes. I'm just expecting it one. Now one more thing, a multi-cluster warehouse and query acceleration. So when I click on multi-cluster warehouse, it will ask some questions. So it will ask, so minimum, so when it will start. Okay, so suppose you written a query and you have just started executing, but the query is very large. Try to understand. Like it is some a very complex query. That time, your code will not be able to execute with a single warehouse. That time, it needs a multiple clusters at a time so that it can perform MPP. So it gives us the option that how many minimum clusters you need one and how many maximum clusters you wanted to get started. So four. And there is a most important thing, that is a scaling policy. A scaling policy is basically told you standard scaling policy and economy scaling policy. This we will discuss. Standard prevents minimize queuing of workloads. So if some query is in queues, so if you have chosen here policy, scaling policy as standard, then automatically the clusters will get started and you will start you will not, your codes will not be in queue, or your like codes will not in the queue. Okay. So these things we have, like auto resume, auto suspend after 1 minute of inactivity, multi-cluster, I will now discuss. Minimum cluster is 1 and maximum cluster is 4. A scaling policy, let me show you. If you not select this, and then we will create it. So here you can see that we have only one cluster and it is strategy started. Okay, when it is was started, you can see size, access, status started, cluster. It has only one cluster running, not queued. Any query, which query number of query is running? 0. Number of query is queued? 0. Who is the owner? Account admin. When it is resumed? Just now. And that is source is constant. When you do this, just remember the demo W warehouse that we have created. Now come in home. If we want to go in sheets, come in projects, and here you can see. Now, when you come here compute warehouse is there. You can easily see the demo warehouse. And the warehouse which is started will have green dots. So this was started. You can use it like execute this, and you have done. Okay, you can execute this. Now, uh, here you can see more details about this. So here we have status suspended because we have this not. Now size is extra small, minimum cluster count is 1 and maximum cluster count is 1. Scaling policy is standard, auto suspend 60 seconds where auto resume we have enabled. Now if I want that, I have done only to show you that this data warehouse has a minimum and maximum is 1. Now I want to edit. So come here and edit. If I want too much details, I want to increase the clusters. So minimum cluster is 1, I want to make it a 4 and policy is standard. We'll discuss the standard policy and save this there warehouse. So once you save it, you can see the clusters. Number of cluster is 4. Earlier what you were showing? 1. Okay. So you can come here in your projects, come in demo lecture 1 and this is a sheet. Here you can easily see the demo warehouse, can move note the details. Maximum cluster count is 4, minimum cluster count is 1. So a scaling policy is standard. So this way we have created our uh, virtual data warehouse. You can create many virtual data warehouse if you are having the access of account admin or sysadmin. Okay. Now this is what we have created with the help of uh, mm, GUI. But if I want to create a virtual warehouse by writing the SQL code, in that case, what I should do? In that case, how I can create? So in that case, you can also create. Just a minute. Now a minute. So you have to just write create or replace, okay, warehouse and see. Now I am putting my warehouse name demo 2 underscore wh. Okay. Now earlier we are getting some features now for each warehouses. We are getting some features, some qualities. So we can write this qualities manually, like width, and you can write warehouse size underscore size equals to x small or small. Okay, so there I have selected my size. Auto suspend underscore suspend equals to 300 seconds. That is what scaling policy was there. SCALING scaling underscore policy equals to what we need. If I need economy, you'll read this economy. Okay, and if I want to add more, so first we will create till here and we'll. So demo 2 warehouse has been successfully created. If I want to see, so here you can see demo 2 warehouse is created and it is the some details like auto resume enabled, auto suspend 300 seconds, scaling policy 3 economy, minimum maximum clusters. You can also view this from here. If I have account admin, that case, if I want to see, so come in here and come in warehouses. So you can see, you can just refresh it. You can see we have a demo 2 warehouse and we have this size is small. Now you can edit this from here as well. Edit. Okay. But I will show you that how you can. Okay. So you can update it from here as well in the same like minimum cluster count equals to 1 and maximum cluster count equals to 4, or it has already started running because we have not uh, we have it it is a standard that whatever the warehouse we will create, it will automatically start running. If you don't want that case we have to write initially ini, ini, initially suspended equals to true. So in that case, what will happen? It will, when you create this now, so you can see the warehouse is created. Okay, but if you will not run this, it will not run. It will be stopped. Okay, so you can see now demo 2 warehouse is not running. Here, compute warehouse is running. Okay, so you can see that more details from here as well. Demo 2 warehouse we created. Minimum clusters, maximum clusters. You can see coming here. You can also see the details which you have from warehouse. And see, refresh it. And see we have a 4 clusters. Now it is not automatically running because our feature is this. Then you come here, edit, and see uh, auto resume is there, auto suspend is there, standard. So here you are getting more, you are getting more options. You are able to customize it more rather than creating it directly from database GUI. So this is what we have created. We can also add comment as well. Comment equals to this is the sample data house which was created. So you can use this. So this is what the data warehouse, sample virtual data warehouse we have created. Okay. Now, here we saw two things. While creating a virtual data warehouse, here it was giving us the option, edit. It was giving us the option to select this thing, scaling policy. So we will be discussing this scaling policy and then we will be moving out further. Okay. So come here. We discussed, we done with our setting up a virtual warehouse. So we saw that how we can create a virtual warehouse with the help of having admin access and with the help of, okay, one more thing is there. We can edit that virtual warehouse which we have created. Okay. So how you can do? You can write like this: alter warehouse. This is the name, and set. If I want to reduce this auto suspend equals to 30 seconds. So you can update it. So now the auto suspend has been updated to 30 seconds. How you can see demo 2, you can click here and you can see auto suspend is 30 seconds. So you can definitely alter the warehouse which you have created. This alteration can be done with this GUI, okay, or you can write the code for this data warehouse, creating a virtual data warehouse. Okay. Now we will be studying about the two policies which were coming while creating a data warehouse. Okay. So first policy is standard policy. And what is standard policy? Suppose let us let us understand this through an example. Okay. There are two types of policies, scaling policies. One is a standard and second one is economic. So what are different features of this? We will be studying. Suppose we have a complex query. Now you want your query to be executed fast. You cannot wait for the a second. Okay, you cannot wait for the second. You want that our query should be executed fast, and in that case you have to choose a standard policy. But if you want that, you can little bit compromise with your mm, uh, see, bring you in the situation. We can discuss this. Discuss this. See, pricing in a Snowflake is happens about how much credits you have used by time. Okay. So how many credits you have used by time, or how many credits you have your credits were used by your compute engines. So whenever you have a large complex queries and you want that your output should not be delayed, it should be a very quicker and faster way. And in that case, you have to spend a good some amount of your credits so that your work or your query can be executed in a proper time manner. In that case, you have to choose a standard policy. But when you want that it should your query could take some time, but you want to save the credits. You do not want that your multi clusters or compute engines which we are aligned with the virtual data warehouse should not start or you want to pay some less amount of credits to Snowflake, that's time you are choosing uh, economic scaling policy. So here is a basic which I am saying. A standard policy. The key characteristics is suppose there was query like it has a join. Okay. So first a query was executing. Now there is one more query. It is still waiting in the line. Okay. It is still queued. So in that case, there could be two scenarios. Suppose I query it is still in the queue. Either start a new cluster or wait for the first query to be executed. Okay, so in that case, in case one, suppose I just not able to click it in that time. Suppose we have a 10 queries or 5 queries. Okay, now query 1, query 2, query 3, query 4, and query 5. So in a standard policy, what happens? Suppose query 1 is there and it is executing, and we know that it will get executed for some minutes. So in that case, either we have to wait, these queries will either wait in the line or queued up, or there can be a scenario that start a new cluster for execution of each query. Okay, so in that case, a new cluster has been started and your query will execute it quickly and you will get the output. This is a scenario one, and this standard policy comes into this. But in economic policy, what happens? It will see it. We have query one, query two, query three, and query four. These are all the same queries. Now it is watching that query one is getting operated by cluster one. Then it is our system, when we will select economic policy, now our system will see that how much time it will take the query to be executed by cluster one. If it is taking like very much less time or less time, so it will not start a new cluster right now. It will see that if all will be executed in that particular duration, or your query will have to wait. So it waits for some time so that your query gets completed. So this is what it is saying. If you read this, you will get to know. I think I helped you to understand the proactive scaling. Here the scaling like clusters gets started as soon as it sees that queries are in the lineup, it gets just started. Adds a new clusters as soon as queries are in queued. Okay, so we saw that in query 1, query 2, query 4, query 5. If our other queries had to stop, in that case it will start it's a new cluster as soon as, and it will execute all the queries. So if there are 5 queries, so minimum 4 clusters will get started. Whatever the clusters which you have mentioned here, like minimum and maximum clusters, number of cluster will get activated at that time. Okay, so your queries don't have to wait whenever you are selecting minimum or maximum count. Focus minimizes query wait times and optimizes performance. As the number of clusters will get increased and it will start simultaneously, in that time you don't have to wait, and it will increase our performance. Behavior. So when it starts, as soon as the current cluster reach maximum capacity, high concurrency or resource usage, a Snowflake immediately starts spinning up additional. Suppose we have a cluster 1 and it has reached to our top level maximum utilization. That time it will soon start cluster 2, cluster 3, so that our queries do not have to wait in the line. We'll start spinning up additional cluster up to the maximum configured number. Oh, here it is the maximum configured number, whatever you have given. Okay. Now, once the workload decreases, Snowflake quickly removes idle clusters. So whatever the idle clusters we have, suppose there are 4 clusters were started. Okay, so initially all the 4 were active. Now it shows that there are only 2 queries are left. So it will see that it will get executed by this C3, C4, and it will immediately shut down this C1, C2. Okay, so this is what saying that as soon as it sees that workload is getting decreased, it will automatically switch off the clusters. Okay, because the Snowflake charges according to our storage and what are the amount of clusters which has been, whatever the time the clusters have been executed. Okay. Now come in the economic policy. In economic policy, as we saw that we can wait in a queue because uh, Snowflake sees that is the query which is in queue can be easily executed by the cluster which is running. So conservative scaling is there, adds cluster more cautiously. So in standard policy, the cluster gets started as soon as it's in the it shows that queries are in a queue. But in snow economic policy, cluster watches that is the coming queries will get easily executed within a given time frame. If gets executed, then in that case it will not start other cluster. Focus reduces cost while maintaining acceptable performance. Okay, so it checks the performance and it will reduce the cost. Behavior. Snowflake waits longer before adding clusters even if queries are queued. So here it is waiting that if the queries are queued, it will see that it will measure first, will it be executed easily by the cluster one or we have to start. Then that if it is finding that it will take more time, then it will start their own new clusters. If queued query is resolved with the existing cluster, no new clusters are added. This is what I was discussing. Similarly, it delays shutting down cluster to avoid unnecessary scaling up. And in a standard policy, the scaling up, the clusters gets shut down as soon as the query gets executed and completed. But in economic policy, it is not like this. It waits that query once a query gets uh, completed successfully, that time it closes down the clusters. Okay, so here is the some description. Now there are two things. One is when the cluster gets started and when the clusters are switched off between these two options which in both the policies. When a new cluster gets started and when the cluster will get switched off or down. So here it is mentioning that standard prioritizes performance by starting additional clusters quickly to prevent query delays even if increases the resource usage. So here you can see in a standard the performance is the priority and our time is a priority. We don't want to wait in the queue for our queries to be executed. And when the cluster gets started, the clusters are added immediately when queries are queued or when the workload exceeds the capacity of active clusters. So I have created cluster C1 and our Snowflake shows if you have selected a standard policy, then our Snowflake shows that this query will not be executed by the active cluster. That time it will soon start the new cluster and start executing. And in this is scenario, in scenario 2, what as soon as it will see that their queries are queued, that time it start executing. And when the cluster will slow down, the clusters are removed after 2-3 successful evaluation conducted at 1 minute intervals confirm that other clusters can handle. So it will check that once every query will get executed, it will check that will it be still it will be all the queries will be executed by 1 minute. So it will shut down. But in economy, what happens? You can read. Focus on cost saving by keeping clusters fully utilized. Here, each cluster is utilized fully and delaying the additional of new clusters. It allows queries to be queued for some time because it sees that if the query gets executed by not. So what is the outcome? Outcome is basically may result in longer wait times for queries. We have discussed. So when the cluster starts, say here it checks for additional clusters are added only when the workload is estimated to require at least 6 minutes of continuous processing. So if there is if you see that it will still need 6 minutes more to execute, that time it will start their clusters. Clusters are removed after 5 to 6 successful evaluations. Confirm that fewer clusters cannot. And when it is closed, it will continuously
see that how many clusters are required. It will check it for 5 to 6 times, and when it will confirm that these clusters will handle the query execution, that time it will close itself. Now this is the same thing. Scaling approach, proactive immediate scaling, conservative delayed scaling. Performance is always minimal wait times, there cost saving. Cluster shutdown immediate, but it is take some time. Best for high concurrency plus performance critical. So when it is used, suppose there is a live data we need, or we need a live streaming of analytics. That time we are running this standard policy. But if you are doing it for yourself or not for an industry purpose, that time you can easily run economic policy. Basically, the cost saving happens in a economic policy, but in a standard, the cost is not saved, money is not saved, but you will get your output more faster and more better way. So that's all for today. Thanks and watching for this lecture. Thanks and have a nice day.